This second video on angles and arcs inside circles, or round and dealing with circles, will have two different locations. Our first video dealt with angles that were located on the circle. The vertex was on the circle. This video, our angle is going to be located either inside but not at the center. So these are not central angles, so inside the circle, not at the center, and outside of the circle. Because we have two different policies, two different procedures, or two different theorems that we have to understand to solve these. The first, and they're very similar, but also very different. But the first idea is that, let's say I'm solving for x here. X has an angle that opens up, and it intercepts this arc here. So the location is at the center, it opens and intercepts this arc. But let's recall back to first semester. This angle is x degrees, but this is a vertical angle, which means it's also x degrees. And so I can also say that x not only opens up down there, but it also opens up here. And in doing so, it intercepts this arc as well. So x actually intercepts two different arcs. Same thing can be said about y. Y opens up here and intercepts this arc, and then it opens on the vertical side and it intercepts this arc. But we're going to worry about y in just a second. This first property here to find x is because of the location is inside my circle. Very important concept here. The location of the angle is inside my circle. The measure of my angle is going to be equal to exactly 1/2. Now if it's on my circle, it's 1/2 of the arc. But here it intercepts not one arc, it intercepts two. So it's exactly 1/2 of the sum of the intercepted arcs. So I'm going to just say arc 1 plus arc 2. It has to be the two arcs that are intercepted by that angle. Which means in this example, x, which is my angle, is half of 44 plus 152. That makes x 98 degrees. Now, y, I don't know exactly what these two arcs are, but I could figure out what they add up to. I know that 44 and 152, whatever 360 minus those is what these two add up to. Half of that is y. Or I can just go back to unit, I forget which unit this was, probably unit 1, and recognize that these two angles are a linear pair. That y plus x has to be 180 degrees. And now that I know x is 98, just take 180 minus 98. That gets me 82 degrees for y. The second example here is going to be similar but slightly different, because instead of my angle being located inside my circle, my angle is now located outside my circle. But similar to this concept, when this angle opens up, it does not intercept one arc, this arc. It actually goes through this circle and winds up intercepting two arcs. So it will first, closest to the angle, intercept what I'm going to call our small arc, because as the angle keeps opening up, it gets bigger. The second arc it intercepts is always going to be the bigger arc. So, what's the property? It's almost identical to this, except it's not a sum. It's the difference. In this case, the measure of my angle is going to be equal to exactly half of, I'll just call this my big arc minus the small arc. This example then, x is equal to exactly half of 104 minus 28. And I can go ahead and calculate that and find x to be an angle of 38 degrees. The second or last example on this is an awesome problem. And this problem is going to be something that you will see on assessments because it's really putting together all of those pieces of the puzzle and recognition of angles that are inside versus angles that are outside, and how everything is kind of coming into the forefront and playing a role here with these two different types of problems. We could make this even more challenging by adding other variables, like I could put z here, I could put w here, and we could find what all of those measures are as well. I'm not going to do that for now. For now, I want us to focus on the two angles that we're looking for. X is inside, so I know that we'll just use the variable. X is going to be, because the angle is inside, exactly half the sum of two arcs. So first arc plus the second arc. We got to figure out what those are. But then y is located outside. So when I'm calculating y, it's not going to be half the sum, it's going to be half the difference of a big arc minus a small arc. The good news is x opens up this way and intercepts this arc, 115, and then the vertical angle opens up this way and intercepts this arc, 40. Okay. What's good about that? Well, y opens up and intercepts the 40 and then keeps going and intercepts the 115. These two angles actually open up and intercept the exact same two arcs. So the 100 and the 105 we don't need in this case. We're only focused on inside here. So x is going to be equal to 1/2 of my 115 plus my 40, whereas y is going to be equal to 1/2 of big, which is 115, minus small, which is 40. So in this case, when I calculate this, we should get x to be equal to 77.5. Decimals are fine. And we should get y to be equal to 37.5. Just to add on to this, extend this just a little bit, if I did ask you to find the measure of this angle down here, and I called that angle z, its location is on the circle. So z, or the measure of angle, this green angle, which I'll just call it angle z, if I call that point z, is going to be equal to exactly half of just the intercepted arc. That angle opens up just to the 40. So it's going to be 20 degrees. And I could do something similar here and call that w. Well, that's going to be exactly half of its intercepted arc because it's located on my circle. So it's all about location, on, in, or out. The only thing not represented in this exact problem would be a central angle. The central angle is equal to the intercepted arc.